Right, hello Year 8. So today what we're going to do is we are going to be looking at atomic mass and atomic number. Now we did look at this a little bit last lesson when we were looking at the structure of the atom, but we sort of need to understand a bit more about what these mean, sorry. So the first task that I'm going to get you to do is in your assignments, there is essentially a copy of this sheet. If for some reason you can't print this out, what you'll need to do is you'll just quickly need to get a ruler and a pencil and just copy a blank periodic table into your book. Okay, so what I would like you to do is for the first 20 elements in the periodic table, I would like you to write the symbol, the atomic number, and the atomic mass. Now, if you've got a revision guide to help you, that's fine. If you wish, you can jump onto the internet and do some research to help you find this out. Okay, but essentially, yeah, just the first 20 elements. So I suppose what I mean by that is the first elements going up to or with an atomic number, and that's really important, of 20 or less. Okay, so the first 20 elements. So don't think just, all right, I'll just do the first 20 over here or the first 20 over here. Where do they actually go? Okay, so you do have to think about this. So pause the video now, print this off, or quickly sketch into your book. And for the first 20 elements, I want the atomic symbol, the atomic number, and mass number. Okay, so that'll probably take you about 10-15 minutes to do that because you're going to have to probably have a quick research on that. Okay, off you go. Okay, so welcome back. So what you should hopefully have by now is there's two ways you could do this. You could have compressed the first 20 elements like this, and you can see here you've got the symbol and the atomic number, although this example, this is obviously atomic mass. Or if you'd drawn it out properly, like this, your first 20 elements would have had hydrogen, helium, lithium, beryllium, boron, going all the way across here, ending with the atomic number 20, which is calcium. So essentially, it would have just been these ones here. So just sort of draw a bit of a loop around them. It would have been up to about, yeah, there, like that, and then these ones as well. Right, so those are your first 20 elements ending with calcium. Okay, now a couple other little things about that. It also asked you, can you identify the metals? Now, essentially the metals are all on this side of the periodic table. So it's this little zigzag line here that essentially, which starts there, identifies the metals and the non-metals. So essentially all of these are non-metals and all of these ones over this side are metals. What you're going to learn a bit later is that these metals on the very far side here, they're very special, they're reactive metals, but we're going to talk about those a bit later. Right, so you've had 15 minutes and you've drawn out your periodic table. What we're going to do today is focus on the atomic mass and the atomic number. So all of you should state what the mass and atomic number represent. Most of you will be able to describe how mass and atomic number are used to calculate the number of protons, neutrons, and electrons in an atom. And a few of you will be able to do this independently and calculate them from the periodic table. Okay, so think about what we learned last lesson. We know there are protons and neutrons and electrons in the structure of an atom. Okay, we know that. But how does this link to mass and atomic number? So I'm going to put this link in assignment. So you'll need to pause the video once more and then click on this link. And then I would like you to write mass number and atomic number. And using the video as your guide, write down your best definition for that. So pause this video, click on this link in assignments, and then once you've watched the video, write mass number an atomic number and your best definition for it. Okay, pause the video now and off you go. Okay, so welcome back. So calculating the number of protons and neutrons, we can use the atomic number and the mass number. Now, hopefully you remember certain things from the last lesson. For example, both protons and neutrons have the same mass. They have a mass of, we call 1. Okay. Now, it's essentially the number of protons that make an atom what it is. So, for example, sodium has 11 protons. Okay, that's what makes it sodium. If it had 12 protons, it wouldn't be sodium anymore. It would be magnesium. So this number is what makes the atom what it is. Okay, now this number essentially adds bulk to the atom. I mean, it's a bit more complicated than that. It does do certain other things, but essentially, this is the number which makes an atom what it is. If this number changes, then the atom changes into a completely different substance. Okay? So, sodium has 11 protons. How many neutrons does it have? Now, we can work this out because the mass number is the number of protons and neutrons combined together. So, we've got 11 protons, but this is the protons and neutrons together. So we just need to do a little bit of simple arithmetic. Okay, so 23, 11 of which we know are going to be protons. So how many neutrons are there? So what you would do is 23 minus 11. And that tells you how many neutrons there are. So 23 minus 11 is 12. And so therefore, for sodium, although we've got 11 protons, we must have 12 neutrons, okay? Because that brings us up to 23. So we can use that rule to always work out how many neutrons there actually are. Now, there is a couple of other things you need to recall. Protons have a positive charge. Neutrons have no charge. So overall, at this point, our sodium atom would have 11 positive charges. But sodium is neutral overall. And neutral means all these positive charges must be balanced by negative charges, which hopefully you remember found in electrons. So how many electrons are you going to need to make sodium neutral? Okay, it's quite obvious. You're going to need 11 negative charges. You're going to need 11 electrons. Okay, and so that's how many sodium has. 11 positive charges means you've got to have 11 negative charges to balance it out. Okay, so your next task is this. I would like you to use your periodic table, and again, you might need to pull one up off the internet. I want you to write down these elements, and I want you to work out the number of protons and neutrons. So let's do a simple one. Let's just do one together. So nitrogen has an atomic number of 7 and an atomic mass of 14. Right, so how many protons does it have? Well, the atomic number is the number of protons. That's easy. So it has 7 protons. How many neutrons does it have? Well, the mass is 14, 7 of which we know to be protons. So therefore, to bring up to 14, there must be 7 neutrons. Okay, so that's that one. I'd like you now to just pause the video quickly and find these other elements in the periodic table and just tell me how many protons and neutrons there are with each one. That'll probably take you about 5 minutes. Okay, so pause the video now and do that, please. Okay, welcome back. Now, we touched on this question, how do we find the number of electrons? I'm not going to go into great detail any more than I already have done. I'm simply going to leave you to work this out. So your next task is also an assignment, and it's the sheet that looks like this. Now, this is quite similar to last week, so it shouldn't take you too long. In each case, what you need to do is using the description of the atom, so the atomic number, the atomic mass, and the symbol, work out the atomic number, mass number, number of protons, number of neutrons, number of electrons. Some have been partially filled in for you. This will require you, in a couple of the cases, getting the calculator out. Just one thing you might have noticed. Here at the bottom, U appears twice, but the numbers seem slightly different. Just a very quick explanation of that. They are both a different type of the element U, and I'm not going to tell you what that is just yet, but they're what are known as isotopes, which means they're both U. Actually, I will tell you, it's uranium, and you'll see 92. So they're both uranium because that's what makes an element what it is. But this number is different, and that should lead you to a conclusion about them. But anyway, I'll leave that to do now. This should probably take you about 10 minutes or so to fill this in. So you need to either download it from assignments, or you can just write the answers into your book if you're having trouble printing it out. Okay, so very well done today, everyone. These 4 words, just make sure you are really, really clear about the meanings of these words. We are going to be doing some slightly more complex stuff next lesson because we need to know about the structure of electrons and how they're arranged within the atom. But other than that, that is it for today. So, well done. And if you have any questions, as always, I will be online. Off you go.